Hey, Matt 143. We're going to try to talk to you guys today about scientific notation. And so, if you'll follow me down to the paper here, we can think about 10 and 10 to the 1 power. That's where I want to start off with. And of course, this equals to 10. Okay? Now, 10 to the 2 power, it is of course equal to 100. You'll notice that there are 2 zeros. Okay? Well, that's all good. 10 to the 3 is equal to 1,000. 1, 2, 3. Okay, and so we're starting to notice a tendency. We can come here and say 10 to the 0, and of course we know that's going to be equal to 1 by definition. 10 to the negative 1, and of course this is equal to 0.1. But you notice that there is 1 0. Now this time, because it's a negative 1, you have to move the decimal to the other way, didn't you? Okay, and so we're going to talk about that and how to affect that. But if you're doing this on your calculator, this is the negative button, not the subtract. All right. At any rate, that should give you a quick thing to look at, but let's continue on with the next clip. Okay, so the next thing to do is to think about how you would convert one number into scientific notation that was not in scientific notation. Okay, and so here we have an example like this. Okay, what is that in scientific notation? Now here, the decimal needs to go this way, doesn't it? Okay, so the number has got to be 5.7 because in scientific notation, the decimal always belongs before the first 2 significant figures. The next thing that scientific notation always has is a times. It always has a times 10 to the power. That's just what scientific notation does. It has 10 to the power. Now, I'm not going to talk about which way this arrow goes, whether it goes to the left or whether it goes to the right. What I am going to talk about is this is a pretty small number. And so, since it's a small number, it's going to be negative. All right? Small number. If that number is big, then that is positive. Okay? But that's a negative. And now we count how many times. 1, 2, 3, 4. Okay? It moved 4 times. Okay? Good. All that is good. Okay? And that's how we convert from scientific notation, okay, over to that's how we convert fixed decimal over to scientific notation. Now this is still scientific notation. It just has a capital E instead of a times 10 to the. All right. You can find a times 10 to the button or a capital EE sometimes on a calculator for scientific notation. All right. We'll continue this in the next segment. Okay, so we made it to the third segment now, and here what I want to talk about is if you had a number in scientific notation, how would you convert that back to fixed decimal? So again, we'll come and take a look at what we have here. This is, of course, the constant of universal gravitation, okay, or capital G. But I don't suppose you really care about that unless you wanted to take astronomy. All right. Well, okay. We know that the 6.67, and now this decimal is going to go this way, or it's going to go this way. I wonder which way it's going to go. Okay. Well, it's mystery. Not really. But let's try to figure it out. Now, because we see that negative sign there, we know that this number, when it's written out, is actually supposed to be really small. And because gravity is really weak, this number is extremely small. It's extraordinarily small, in fact. So, if the decimal were to go this way, then you wouldn't be making a big number, would you? That's no good. All right, so let's try that again, 6.67. But this time, we know we need to move the decimal 1, 2, 3, 4, 5, 6, 7, 8. Oh no, I ran out of room. What do I do? We do it again, 6.67, and give yourself plenty of room this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, what goes in the blanks? Where there's nothing in those swoops. And of course, that's exactly what you do. You put zeros there. All right, and so now you can see actually that this number 6.67 is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 6, 6, 7. Okay. There are 11 zeros there, wasn't there? You have to use 1 to hold your decimal or place setting, but you can do that. Then there will be 11 zeros. All right, so that's how you convert. One word of warning here is you cannot put this number in into your calculator. You must use scientific notation in order to input that number into a calculator because it's so small. Your calculator only has 10 decimals, not 11. All right, so that's a good point here. All right, give me 5. You made it to the last part or segment of this video, which is one final look at scientific notation and why you would want to use scientific notation. So, of course, in astronomy, we talk about the mass of the Earth. And as everybody knows, the mass of the Earth is 5.97 times 10 to the 24 kilograms. All right. Now, how much is that equal to in fixed decimal? And of course, when you figure the answer out to this one, you'll see why scientists would like to use scientific notation on such numbers. Okay, but we'll come over here and we'll say, okay, it's 5.97, and we'll start swooping. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I know you thought I was cheating on those last several swoops, but I knew I was going to run out of room. Holy moly. Now that's a lot of zeros. That's how many zeros, with the 597 in front, of course, that you won't have in the bank. That's what you want. Okay, so at any rate, this is 597 hexillion, and then there's going to be 1, 2, 3 more. 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 That's a lot more. 1, 2, 3 more. 1, 2, 3, 4, 5, 6 times 3 is only 18. 21. And oh my goodness, I still didn't leave room. Okay. That's a lot of zeros. Anyway, of course, this one is probably closer to what I have in my bank account, just a plain old 0. But at any rate, you can see why you would not want to, or could not even type that into calculator. And so you could see why you would want to use scientific notation.